Before the appearance of high voltage gate driver ICs, engineers were using gate drive transformer to drive high side switches in high voltage circuits. The integrated high side drivers are convenient and use less space, but they have significant turn on and turn off delays. In this video, we'll see about the transformer coupled MOSFET driver, its advantages, and working. So let's start. As we have seen previously, driving a high side MOSFET is quite tricky. We fool this high side MOSFET. If you want to know how we do it, then please check out these videos. Let's see this circuit diagram. When we see a transformer coupled gate drive, the primary side of the circuit is connected to the gate driver circuit, which provides gate pulses. This circuit can be a low side gate driver, which switches from voltage of VGS turn on to the ground, and secondary side is connected between the gate and source of the MOSFET. This MOSFET is a high side switch. It will work even if there is a load on the lower side. In this way, when we provide the gate pulse at the primary side, the voltage gets induced at the secondary side due to electromagnetic induction. And this induced voltage is sufficient enough to turn on the high side power MOSFET. The properly designed transformer coupled gate drive has minor delays, and it can operate across higher potential differences. There are some important features of transformers and their correlation to the gate drive transformers. The two separate primary and secondary windings provide galvanic isolation between two circuits. Also, we can adjust the turns ratio between primary and secondary, which allows us to do voltage scaling. In the gate drive transformer, we don't require voltage scaling, but isolation is very important for power electronics applications where the power levels are very high. Apart from this, in order to use transformer-based isolated gate drive technique, usually we don't need to use a different isolated power supply for the secondary side of the transformer, so the overall complexity and component count is less. For the starters, we'll look at the single-ended transformer coupled gate drive circuits. These gate drive circuits are the easiest to understand. A single output PWM controller drives a high side switch, as we saw while working. But there are some modifications needed to be done in this circuit for optimum gate driving. We need to place the coupling capacitor in series with primary winding of the gate drive transformer to provide the reset voltage for magnetizing inductance. Without the capacitor, there would be a duty ratio dependent DC voltage across the winding and the transformer would saturate. The voltage across this capacitor is the multiplication of duty cycle at which the power electronic converter is working and driving voltage. This voltage changes with the duty cycle. The capacitor and gate transformer in the form of magnetizing inductance creates an LC oscillator. And if there is a sudden change in duty cycle, this LC oscillator gets excited. To minimize this, we have to use a low value resistance in series with the capacitor. The value of this resistance should be optimum. It should be high enough to limit the gate current, eventually the switching speed of MOSFET. Also, if the resistance is too small, then it may result in unacceptable voltage trace across the gate to source terminals. There is a limitation of the duty cycle in this type of driving circuit. If the duty cycle is higher like in buck converters, the circuit is unable to provide adequate gate drive voltage. The coupling capacitor voltage increases with an increase in duty cycle. Also, the negative bias during turn-off time increases due to the transformer magnetizing current, and the turn-on voltage decreases. But adding two small components on the secondary side of the gate drive transformer can prevent this situation. A very commonly used technique to restore the original voltage levels of the gate drive pulse is to connect a second coupling capacitor and a simple clamping diode. These are used to restore the original gate drive amplitude on the secondary side of the transformer. And that's how a single-ended transformer driver works. There are some important points that we need to keep in mind while using a transformer. To avoid time delays in the gate drive path, a low leakage inductance transformer is very important. Well, ideally, the transformer doesn't store any energy, but the flyback transformer is made up of coupled inductors. Nevertheless, a small amount of energy is stored in real transformer in the non-magnetic regions between the winding and in smaller gaps of the core. This energy storage is represented by the leakage and magnetizing inductance. The gate drive transformer handles very low average power, but it delivers high peak currents at turn on and turn off if the leakage inductance is high. Due to that, it increases time delays. As per Faraday's law, the average voltage across the transformer winding must be zero over a period of time. Even a small DC component can cause flux imbalance and eventually saturation of the core. This rule will have a substantial impact on the transformer coupled gate drives, which are controlled by single-ended PWM circuits. The core saturation limits the applied volt-second product across the winding. In PWM, the driver should reserve a significant portion of the switching period to reset the core of the main power transformer in single-ended application. Just like we saw in the forward converter circuit, if you want to know how a transformer resets, then please click on this card. Well, the reset time interval limits the operating duty ratio of the transformer, but this issue rarely occurs in the gate drive transformer designs. This is all about the basic of transformer-based MOSFET drivers. Next time we'll see different advanced types of transformer-based MOSFET driving techniques. Till then, stay tuned. I have added all the references related to these circuits in the description. If you have any query, you can ask me in the comment section or email me. Hit the like button and subscribe to my channel. And finally, thank you so much for watching this video.